Hello everyone. In this lecture we'll see a problem on harmonic as well as analytic function. A problem is show that u is equal to e raised to x into x cos y minus y sin y is harmonic and find its harmonic conjugate. Also determine the corresponding analytic function. Solution. So the given function u is given by u is equal to e raised to x into x cos y minus y sin y. So for this we have to go for first what here, partial derivative. So partial derivative of u with respect to x is dou u by dou x is equal to, so we have to just see that, so here function of x and here also it is function of x, so we'll go for product formula. So I will keep e raised to x as it is. So partial derivative of x cos y, so x is 1 because cos y is a constant, as it is partial derivative of x is 1. So minus, so y sin y, it is purely constant with respect to y, with respect to x partially it is 0, plus keep the bracket as it is, that is x cos y minus y sin y as it is. The partial derivative of e raised to x with respect to x is e raised to x itself. So therefore on simplification take e raised to x common. So dou u by dou x will be, if you take e raised to x common, so we are going to left cos y plus x cos y minus y sin y. So this is the value of what here, dou u by dou x. So once we get dou u by dou x, now again we'll differentiate this dou u by dou x once again with respect to x partially. So we'll get a double derivative, means it will be dou square u upon dou x square is equal to, so again here it is again product formula, keep e raised to x as it is. So partial derivative of cos y with respect to x partial is 0, plus, so cos of y as it is, partial derivative of 1 with respect to x partial is 1, minus y sin y with respect to x partial is 0, plus keep the bracket this as it is, that is cos y plus x cos y minus y sin y as it is. So partial derivative of e raised to x with respect to s is again e raised to x. So again take e raised to x common and rewrite all the things. So dou square u upon dou x square is equal to, if you take e raised to x common, so 0 leave it, 1 into cos y is cos y, then there is 0 leave it, so plus into this, so plus cos y, plus into plus is plus x cos y, plus into minus is minus, so y sin y. This e raised to x I have taken already before here. So just we'll check here, so anything is same then we can add or subtract here. So therefore dou square u upon dou s square, finally it will become e raised to x into cos y is 2 cos y plus x cos y minus y sin y. So this is a double derivative of u with respect to x partially. Now again u we have to go for what here, with respect to y partially. So our u is, remember the u, e raised to x into x cos y minus y sin y. So therefore, so partial derivative of u with respect to y is dou u by dou y is equal to, you can observe here again, so here e raised to this bracket, so e raised to x is constant, keep as it is, only the bracket we have to differentiate partially, so it will become keep e raised to x as it is. The partial derivative of x cos y with respect to y, so x is a constant, so partial derivative of cos y with respect to y is minus sin y, minus, you can see here it is over, so minus y sin y means, for this we need to keep minus sign outside and apply product formula. So it will become keep y as it is, partial derivative of sin y is cos y, plus keep sin y as it is, partial derivative of y is 1. So therefore on simplification, dou u by dou y is equal to e raised to x as it is minus x sin y minus y cos y, minus into plus is minus sin y. So this is our dou u by dou y. So this is partial derivative of u with respect to y. Once again we have to differentiate this with respect to y, that is it will become dou square u upon dou y square is equal to, again e raised to x is a constant, keep as it is, so minus x is a constant, so partial derivative of sin y is cos y, minus, again we need to go for product formula, put a bracket, keep y as it is, partial derivative of cos y is minus sin y, formula plus, keep cos y as it is, partial derivative of y with respect to y is 1, again minus, partial derivative of sin y is cos of y. So now we'll go for the final simplification. So dou square u upon dou y square will be e raised to x, so minus x cos y, minus into minus is plus, y sin y, minus plus is minus cos y, then this minus cos y. So which will be, you can see that here, so on simplification, so minus cos y it will become minus 2 times cos y. So on simplification, dou square u upon dou y square will be, so on simplification we'll get dou square u upon dou y square. So you give equation number 2 for this and 1 for dou square u upon dou x square. So add 1 plus 2 will get, and we'll check for the harmonic. So if you go for 1 plus 2 gives, so left hand side of 1 is dou square u upon dou x square, and left hand side of 2 is dou square u upon dou y square. Right hand side of dou square u upon dou x square is, if you add with the right hand side of 2, so you will find the answer 0. You can check the calculation, you will get the answer 0. So which implies u is harmonic. So once it is harmonic, then we can go for its analytic function. So by CR equation, dou v by dou y is nothing but dou u by dou x, and dou v by dou x is nothing but minus dou u by dou y. So we know dou u by dou x and we know dou u by dou y, just now we have calculated. So therefore, so on substituting the values of dou u by dou x and dou u by dou y in above, so we'll get here, so dou v by dou y is equal to, so the value of dou u by dou x, that is first partial derivative with respect to x, we got it as e raised to x into cos y plus x cos y minus y sin y, and similarly dou v by dou x will be so if you write minus times dou u by dou y, so if you multiply minus sign inside to the bracket, so we'll get it as, so e raised to x is equal to x sin y plus y cos y plus sin y. So you have to be careful, check these both. So I have substituted the value of dou u by dou x as well as dou u by dou y, but you remember here So we have minus times, so that minus I have applied here, so we got this result. So for this, remember, so I will give this as equation number 3 and this as equation number 4. So integrate 3 with respect to x and integrate 4 with respect to x. So integrate 3 with respect to y and integrate 4 with respect to x. What we'll get, we'll see here. On integrating 3 with respect to x. So if you integrate 3 with respect to x, we'll get v is equal to integration of e raised to x into cos y plus x cos y minus y sin y into, with respect to x means, sorry, 3 with respect to y we have to go. So with respect to y means dy plus, if it is dy, it is function of x. You have to take the arbitrary constant. So which will be on integration. So I will separate here, just see, v is equal to, I will separate integration of, so if it is with respect to y, the function of x will be constant. So I will keep e raised to x constant here. So integration of cos y into dy plus, multiply this e raised to x and x, both are constant. So x e raised to x is constant, only integration of cos y dy minus this, again e raised to x is a constant, integration of y into sin y into dy plus f of x. So we'll go for the integration now. So v is equal to e raised to x as it is. Integration of cos y with respect to y is sin y plus x e raised to x is a constant. So integration again cos y is sin y minus e raised to x. So for this we need to go for Bernoulli's y sin y. We need to apply Bernoulli's formula. So Bernoulli's formula is u and v, keep y as it is. So integration of sin y is minus cos y, formula minus differentiation of y is 1. Again this minus 1 you have to carry. Again integration of cos y is sin y, and again if you go for differentiation of 1, it is 0. Stop it, close the bracket, plus f of x. So on simplification this step, so just see that e raised to x sin y plus x e raised to x into sin y. So minus, so this minus and this minus will become plus. So we'll get e raised to x y cos y. So minus minus plus, plus into minus is minus. So e raised to x into sin y plus f of x will get here. So therefore v will be, so v is equal to, we'll get finally as e raised to x, if you take common, we'll get this one as sin y plus x sin y plus y cos y minus sin y, close the bracket, plus f of x. Okay, or if you simplify again, so sin y minus sin y cancel. So v is equal to e raised to x into, so we'll get here as it is, you open the bracket better, so we'll get e raised to x into a, because this sin y cancels, e raised to x into x sin y. So we'll write that one, it is sin y, then e raised to x into y cos y plus f of x. So this v, we got it finally now. So now similarly we have to go for equation 4 and we have to go for integration. So on integration, on integrating 4 with respect to x there. So if you integrate with respect to x, we'll get what here. So v is equal to, we'll get as, so what equation 4 I will show now. So this is our equation number 4. So remember we are integrating with respect to x there. So at that time we have to go for each and every, at that time y term will be constant. So at that time sin y is constant, y cos y is a constant, and sin y is also constant. So let's see here. So at that time you take sin y constant, so we'll get sin y, I will take constant, so we'll get integration of x e raised to x dx plus y cos y is a constant, integration of e raised to x into dx plus sin y is a constant in the third term, so e raised to x into dx plus arbitrary constant g of 1. So therefore v is equal to, so sin y, so we need to go for product formula or else by parts, so you will get x e raised to x minus e raised to x. So keep x as it is, integration of e raised to x minus differentiation of x is 1, leave it, so integration of e raised to x is again e raised to x itself. So plus, so y cos y as it is, so integration of e raised to x is again e raised to x itself plus sin y as it is, so integration of e raised to x with respect to x is what here, e raised to x plus g of 1. So therefore on final rearrangement this step will become, so v is equal to, will get, so after cancellation and all, so you can see that, so because sin y into e raised to x minus times and this plus times cancel if you open this bracket, so we'll get finally v as x e raised to x into sin y. After simplification I am writing this step, plus e raised to x into y cos y plus g of y. So you check, we got two values of v here, so one value, so check the terms, x e raised to x sin y, x e raised to x sin y, then plus e raised to x y cos y, e raised to x y cos y, and here f of x g of x. So both the terms are same, only f of x is extra, g of x y is extra. So therefore choose f of x is equal to 0 and g of x is equal to 0. So if both become 0, so then you can observe here both the terms will become same. So there, which implies, so common v will be, it is x e raised to x into sin y plus e raised to x into y times cos of y. So this is our required harmonic conjugate. So with the help of this harmonic conjugate, so we can go for what here, analytic function. So now the analytic function is, that is f of z is equal to u plus iv. So we know u value from the question, v value just now we got it, then we'll get f of z as, so f of z is equal to the value of u from the question, it will be, it is e raised to x bracket x cos y minus y sin y plus I times v value is what here, if you see here v value what we got, so it is x e raised to x into sin y plus e raised to x into y times cos y. So putting x is equal to z and y is equal to 0, so we'll get finally f of z as, so here what happens, so cos of 0 is 1, so 1 into z is z here, so but sin y is 0, y is 0, so this term will become 0, so we'll get e raised to z into cos of 0 is 1, so therefore it will become z minus this is 0, leave it, plus I times, so on simplification sin y is 0, 0 into this entire term is 0, plus again y is 0, so this will be 0, 0 plus 0 is 0, so I will write directly 0 here. So therefore f of z will be z into e raised to z, so which is a required analytic function for the given real part u. With the help of u we got a harmonic conjugate v, and which is nothing but our u and v we have applied, and with the help of u and v we got a analytic function which is nothing but z into e raised to z. So hence the result here. So in this way we need to simplify a problem.